All right. So if you go back, basically what happened here is tan 20 is given as lambda, and we have to write everything in terms of lambda. So we wrote 270 minus 20, 360 minus 20, 180 plus 20, 90 plus 20. Everything is 20 plus something. That may be 90, 180, 270, 360. Accordingly, use the formulas. If tan 20 comes fine, we wrote lambda. If cot 20 came, we wrote 1 by lambda. Then finally substitute everything back. We could get express this in terms of lambda. Okay, 23rd question, I think they're asking cos 1 is greater or cos 1 degree is greater. If nothing is mentioned, 1 means 1 radian. And we know 1 radian is 180 degrees by pi, which is 3.14 roughly, which is around 57.2 degrees. And if you take cos 57.2 degrees, which is very close to cos 60 degrees, which is around 1 by 2. And whereas cos 1 degree is very close to cos 0, which is 1. In fact, between 0 to 90, cos graph is like this. At 0, it is 1. At 90, it is 0, it is decreasing. So higher is the value, smaller is the value. So 1 radian is a bigger angle than 1 degree. An angle is bigger, cos value is smaller. That's why cos 1 is less than cos 1 degree. Anybody having, if you're doubt, please stop me. I don't mind. Okay, I'll explain. Yeah, 25 onwards, so practically not much of theory. Only 3 formulas. What is that? Sin square theta plus cos square theta is 1. Secant square theta minus tan square theta is 1. And cosecant square theta minus cot square theta is 1. These are the 3 trigonometric identities. Just manipulating that, so many formulas. For example, here, sin alpha plus cosecant alpha whole square, cos alpha plus secant alpha whole square. A plus b whole square formula, a square plus b square plus 2a. Here also a plus b whole square. When you take sin alpha into cosecant alpha, you can cancel. Cos alpha into secant alpha. This is cos alpha, secant alpha. Okay, now what are we left with? Sin square alpha here, cos square alpha, that becomes 1. This cosecant square alpha, I can write 1 plus cot square alpha. This secant square alpha, I can write 1 plus tan square alpha. There is this will become plus 2. This also will become plus 2. That is this 2 here and 2 here. So when you take a plus b whole square formula, the 2ab term became 2. This also 2 into cos alpha into secant alpha. That is also cos alpha secant cancel. So finally we got tan square alpha plus cot square alpha plus some number. That is the answer anyway. They want something plus tan square alpha plus cot square alpha. Okay, I guess this must be 27. Okay. These questions, some of them you have to get a specific idea how you proceed. If you do one way, it will be easier. If you do another way, it will be lengthy unnecessarily. So when you look at 27th question, this one here, I can write cosecant square theta minus cos square theta. You have to get an idea that numerator 1 alone, not denominator 1. Denominator also 1 is there, but there is no point in writing. You'll understand later on why. This cosecant square minus cot square, like a square minus b square, I can write a plus b to a minus b. Here also cosecant plus cot, here also cosecant plus cot, I can take common. I'll be left with 1 here, minus, here I'll be left with cosecant minus cot. Now this cosecant plus cot, this cosecant plus cot, when you take common, will be left with 1, and here cosecant minus cot, and down cot minus cosecant, but both are same, you can see. 1 is here, 1 is here. Minus cosecant theta, minus cosecant theta, plus cot theta and cot theta, everything cancel. We got simply this part is left. So only this part is left. And cosecant you can write 1 by sine, cot you can write cos by sine. It will be 1 plus cos theta by sine theta, not square, only sine theta. Okay, 27. Tan A by 1 minus cot A plus cot A by 1 minus tan A. You have to get an idea whether to convert everything into tan is better or converting sine into cos is better. So trigonometry is actually easy, not difficult. But in the beginning, it appears like questions are lengthy, or somebody may doubt which formula to use where, or which way is to do easier, which way is lengthy. There are no answers to all these questions. You have to just try a lot of questions or listen to a lot of solutions. With that basic, you can get an idea how in a particular question. Or when you try, you'll do one lengthy method, then you'll realize it is not lengthy, cancel it, try another method. After doing like that few times, you will later on, when you look at a question only, will see which is better, or you can mind, you can do some steps and then see which is more convenient. Here, tan I wrote sin by cos, cot as cos by sin. Here, cot as cos by sin, tan as sin by cos, and take LCM. Okay. Then here I got this. Here I got. Here also I got sin A minus cos A. That is here also sin A minus cos A. Here also sin A minus cos A. I can take LCM, and then when I took LCM for this part here, I will get sin cube A minus cos cube A by this. The numerator is A cube minus B cube formula. A cube minus B cube is A minus B into A square plus B square plus A. So this sin A minus cos A, this sin A minus cos A, this is there. And sin square A plus cos square A is 1. I'll get 1 plus sin A cos A by sin A cos A. Okay. What is this question? They gave cos theta minus 4 sin theta is 1. They're asking sin theta plus 4 cos theta. What is going to come? I'm going to call that as k. Sin theta plus 4 cos theta is k, and cos theta minus 4 sin theta is 1. Given already. So just square and add these two equations. These two equations. The second equation is given equation. The first equation is k. Square and add. Luckily, theta will completely get cancelled because here 2ab term is 8 sin theta cos theta. Here minus 2ab term is minus 8 sin theta cos theta. It will get cancelled. Here sin square theta, here cos square theta, that will be 1. Here 16 cos square theta, 16 sin square theta, that will be 16. So finally you get k square equal to 16 and k equal to plus or minus 4. Both are correct. Okay. They gave sin theta plus sin square theta is 1, and cos square theta plus cos power 4 theta is fine. Yeah. So just a manipulation here. So all these are okay. One may say how to get idea. When you get idea on your own, okay, you'll find it. In the beginning, it appears like so. Sin theta plus sin square theta is 1. This sin square theta I want to send to the other side, which is 1 minus sin square theta, which is cos square theta. So from the given equation, I got sin theta equal to cos square theta. So wherever cos square theta is, or like here, if sin theta is cos square theta, what is sin square theta? Cos square theta whole square and cos square 4 theta. So I don't want to change everything. After all this work is done, I basically got sin square theta equal to cos square theta. Now they want this right in the question. In the place of this cos power 4, that is this cos power 4, you can substitute sin square theta. And this first one is cos square theta. You can write cos square plus sin square is 1, or sin theta plus sin square theta is also 1. That is the given data in the question. One thing I should tell upfront, this way of teaching, showing something on the screen and fatafat explaining is not a good idea, because the children need to write on paper, then only they will understand or they digest. But this is a revision class, okay? So I don't want to teach for the same 3 months like the trigonometry once again what I taught earlier. Okay? So I want them to give theory thoroughly and give the solutions to the problems and explain overall gist of it, so that later on they can look at these solutions and understand peacefully. After they look at all of them, I want them to write everything. Then if they have doubts, if I discuss, it will be more fruitful. Okay. But just listening and getting an idea that overall idea is good, nothing wrong. So the point I want to convey to you is, if you're really serious about you want to improve from the basics, I'm not discussing any high level questions here, just the basic theory, and I can say up to IP and mains level type of questions, not like full advanced level questions we're covering here with this. That one will do advanced material. But what I'm expecting from you is, these questions only listening to me will not help, especially in maths. You have to try all these questions once again on your own without looking at solutions. And if required, you can take a help from solution whenever you get out. So coming here, cos power nx plus sin power nx is Pn they defined. They want this value 2p6 minus 3p4 plus 1. If you look at the options, they are given, they're only numbers. Some answer is 2, some answer is 5, some answer is 0. That means it does not depend on x at all. If it does not depend on x at all, we don't have to do such big calculation actually. You can take x equal to 0. You'll understand Pn is always 1. P4 is also 1. P6 is also 1. So 2p6 minus 3p4 plus 1 will become 0. But that is not a nice way. That is just sometimes in exam you don't get idea. Time is not there. You can do by putting some x value, especially in trigonometry. But you should also know, if enough time is there, how to actually properly write a subjective solution than putting 1 or 2 x value. Sin power 4 plus cos power 4, I can write sin square x whole square, cos square x whole square. I want to use this formula, a square plus b square. This is a square, this is b square, as a plus b whole square minus 2a. Based on that, from here to here, I wrote directly, but it should be sin square x plus cos square x whole square minus 2 sin square x cos square x, 2ab. But that sin square x plus cos square x will be 1. That's why I got 1 minus 2 sin square x. Okay, so sin power 4 plus cos power 4 is 1 minus 2 sin square cos square x. This part, using sin power 4 plus cos power 4 as 1 minus 2 sin square cos square, we are going to use many questions later on. Just like that we'll be using. So you have to be a little thorough with this. Sin power 6 plus cos power 6. Sin power 6 is sin square x whole cube. Cos power 6 is cos square x whole cube in the form of a cube plus b cube. A plus b whole cube minus 3ab into a plus. I think all of you know this formula. A cube plus b cube has 3 formulas. 2 formulas, sorry. One is a plus b into a square plus b square minus ab. Another formula is a cube plus b cube is a cube plus b cube. Another formula is a plus b total whole cube minus 3ab into a plus. That formula is used here. I generally write which formula is used also. Okay, this is 1 now. This is 1. I'll get 1 minus 3 sin square x cos square. Now you know P6, you know P4. P6 is 1 minus 2 sin square x cos square x. P4, P6 is 1 minus 3 sin square x cos square x. Substitute it, they're getting cancelled. Some part of it, some numbers are getting added up. You will get some answer. Okay. 35, I think in the question they gave already something. Cos theta plus cos square theta is 1. Let us see what is 35 in the question. Oh, there's something else here. They gave in 35 that sin theta, cos theta, tan theta, they are in geometric progression. If they are in geometric progression, first number into third number is the square of the middle number. So I can write sin theta into tan theta equal to square of the middle number, which is cos square theta. Now what to do? This tan I can write sin by cos, and this cos can go here. Sin will be sin square. So I'll get sin square theta equal to cos. Writing tan as sin by cos, sending one cos x. And this sin square theta, I can write 1 minus cos square theta. This cos square theta goes that side. Cos square theta plus cos square theta will become 1. Okay, so that's how the rest of the solution follow. So finally, we understood by this taking GP, somehow we proved cos square theta plus cos cube theta equal to 1. Now, this cos power 9 is written as cos cube theta whole cube. Cos power 6 can be written as cos square theta whole cube. Cos power 5 can be written as this. This is like a cube plus b cube plus 3ab into, there is, I can write into 1 here, and that 1 you can write cos square theta plus cos cube theta. It will be a plus b whole cube. X plus b cube plus 3ab into 8. But this is 1. 1 minus 1 will cancel equal to. This is should be 37. I don't know something missing. If required, I'll write on the board anytime. Yeah, 34 is a little lengthy question. But, just look at 37, 38, 39 and come back. All right. This 37th question. Similar question was there in advanced material also we discussed later. or we will discuss once again maybe. What is that mentioned in the question? This one, and 1 by 2, three numbers. Yeah, comma. So this whole thing is one quantity, this is one quantity, this one quantity. Three quantities are in AP. Then you can take this plus this equal double of this, which is 1. From that, they want us to prove that these three are in AP. Here, actually, theta and alpha should be same. So we should get some idea about it. Okay. Not by guessing. If you guess, it is easy. If the theta and alpha are same, this will become cos square theta. This will become sin square theta. And cos square theta plus sin square theta is 2 times 1 by 2, 1. But how, without guessing, we'll prove it that theta must be alpha kind of thing. Yeah. Whenever ABC are in AP, you know B minus A equal to C minus B, or you can write 2B equal to A plus. So based on that, this is the first term, this is the third term, is double of this. This secant square alpha, I can take it to denominator as cos square alpha. This cosecant square alpha, I can take to denominator as sin square alpha equal to 1. From this, how to prove theta equal to alpha? I want to convert whole thing into theta or whole thing into alpha, one of them. So what I have done here, I think this cross multiplication only I kept as it is. No, I done cross multiplication, that is this step. I eliminated basically, I don't want cos everywhere. I converted everything to sine. That's what I did. Cos power 4, I can write cos square theta whole square, which is 1 minus sin square theta whole square. I don't want this cos, so this cos square alpha I wrote 1 minus sin square alpha. This cos square alpha also I wrote 1 minus sin square alpha. When I expanded everything, I got this equation, which is actually a perfect square. This equation is a perfect square. This equation is a perfect square, which is sin square theta minus sin square alpha whole square. A minus b whole square is 0 means A equal to B. So I got sin square theta equal to sin square alpha. From that I can tell cos square theta equal to cos square alpha. So wherever cos is there, I can write sin. Wherever sin is there, I can write cos with sin in there. Now, what is that I have to prove? If you look at the question, what they wanted to prove is this, and in between 1 by 2, there in arithmetic progression we have to prove. This is the first term, this is the third term, and middle term is 1 by 2. We have to prove there in AP means first term plus third term, I have to prove double of 1 by 2, which is 1. So this secant I convert into cos, this cosecant I convert into sine. I know cos. Yeah, nothing was done from here. Yeah, cos square theta, I know it is same as cos square alpha. Sin square theta, I know it is same as sin square alpha. That's what I proved just now. Cos power 8 by cos power 6 is cos square alpha. Sin power 8 by sin power 6 is sin square alpha. I got finally cos square alpha plus alpha. Sin square alpha is 1, which is 2 times 1 by 2. Hence, the three things which mentioned in the question, they're in it. So mainly proving sin square theta equal to sin square alpha and cos square theta equal to cos square alpha. That is what is important. Okay, 39. The question they gave, this is also okay, this is also okay. What is that? 1 plus sin A into 1 plus sin B into 1 plus sin C, that is also okay. 1 minus sin A into 1 minus sin B into 1, that is also okay. Now, how to simplify? You multiply these two. 1 plus sin A into 1 minus sin A is 1 minus sin square A. Multiply these two, multiply these two. That should be k into k is k square. So k square is 1 minus sin square A, 1 minus sin square B, 1 minus sin square C, which is cos square A into cos square B into cos square C is k square. When you apply square root, k will come plus or minus cos A cos B cos. Very simple, nothing complicated here. You just get an idea that I have to multiply the two things. Okay, this 41 is a specific question, and in the beginning, when you just started trigonometry, when you write from 10th class, it may be a little difficult to comprehend, but now we can understand a little better. We all know sine theta value is always between -1 to 1. Sine square theta is between 0 to 1. And if you take reciprocal of that, it will be more than 1. I wrote all these things here. Yeah. Sine theta is between -1 to 1. Sine square theta is between 0 to 1. And if you take reciprocal of sine square, 1 by sine square, it will be greater than equal to. If you take any number between 0 to 1, if you take reciprocal or ulta of that, it will be more than 1. So you know this LHS is always greater than equal to 1. But this RHS is less than or equal to 1. I'm going to LHS greater than equal to 1, RHS less than equal to 1. How this RHS is less than equal to 1 is, here I proved here, x minus y whole square is greater than equal to 0. That's a correct statement. One may ask, why did you start with that? That we'll understand later. But you know, something square, for a real number square can't be negative, it will be 0 or positive. And a minus b whole square, I can write a plus b whole square minus 4ab. That is, I can send this 4x by that side and divide with x plus y whole square. This one down here, I got this expression is less than equal to 1. So 4x plus y by x plus y whole square is less than or equal to 1. LHS is greater than equal to 1. How can something more than 1 can be equal to something less than 1? Not possible. The only chance this and this can be equal is both are equal to 1. So when will 4xy by x plus y whole square equal to 1? That is, this should be 0, means x should be y. Only when x equal to y, it will be equal to 1. So LHS and RHS both should be 1. LHS to be 1, theta should be 90 degrees or something. RHS to be 1, x and y should be equal. So only when x and y are equal and theta is 90 degrees, these two can be equal. Otherwise, LHS will be more than 1, RHS will be less than 1, they can't be equal. Many are there. Anyway, whenever till this meeting ends, I did not notice the time. There another 15 minutes is there. Till the meeting ends, I'll discuss what our questions are possible. But I request those who are listening to these classes and they missed the original classes or not done thoroughly at that time, you have to do the mains material questions, at least only odd or only even. If you can do both, that is excellent. And that you have to do by Saturday itself, Saturday evening. Then if any doubts, we'll discuss. After that, we'll start compound language. So 43. Yeah, once again, it is very important to know that root x square is not x. Why? Square root of 9 in our notation in these 2 years, we are not going to write plus or minus 3, we are going to write only 3. If somebody asks you x square equal to 9, what are x values? It can be plus 3 or minus 3. If somebody asks square root of 9, it is only plus 3, we don't write minus 3. If you want to write plus or minus, you have to write outside. But root 9 covers only 3, not minus 3. That is just convention. So that is root of something. The inside one should be positive, not only that. The answer also we are going to take either positive or 0. We are not going to take negative. Because of that, for example, root 7 square, nothing wrong in writing 7. Okay. So another 10 minutes. But root 7 square is 7. But root minus 5 whole square is not minus 5. Rather, it is root 25. And root 25 is plus 5 only. So here when 7 is x, root x square came x. But when minus 5 is x, answer is not minus 5 plus 5. So in the second case, root x square came minus x. So root x square can be plus x or minus x. So I just want to say root x square is equal to mod x. And mod x definition is when x is positive, it is plus x, and x is negative, it is minus x. That's the definition of mod x. Okay, now this question, some people can easily do mistake. What is that? Question is root over 1 minus sin square 100 into secant 100. 1 minus sin square is cos square 100. Somebody can easily think root cos square 100 is cos 100 degrees, cancel, you'll get 1. But sorry, root cos square 100 degrees is actually mod of cos 100 degrees. Root x square is mod x. But cos 100 is negative because 100 degrees is more than 90, less than 180, second quadrant, cos is negative. And whenever x is negative, mod x is not x minus x. So I should write mod cos 100 as minus cos 100. That's why this is minus cos 100. Cos 100 will cancel, but this minus stays there. Because of that, it is minus 1. So I think I mentioned all the details. Root k is b if and only if b is greater than or equal to 0. B cannot be negative. And k equal to b square. Root x square is x only when x is greater than or equal to 0. Root x square is minus x if x is less than 0. What is mod x I mentioned? Once again I mentioned root x square equal to mod x. It is positive. It is x when x is positive, minus x when x is negative. Okay, now these eliminations. I'm sure in other track in the locus chapter, there are at the end there are some questions where you have to eliminate theta by you have to find locus. These are almost same. You can say that trigonometry or that doesn't matter. Basically, you use trigonometric identities and eliminate here. Sin theta, there can be some very simple questions in elimination. For example, m is equal to sin theta and n equal to cos theta. If somebody asks, you can tell directly m square plus n square is 1, theta is eliminated. If m is sin theta plus cos theta and n is cos theta minus sin theta, then square and add again, m square plus n square is going to come 2, not 1. Like that, sometimes squaring and adding is better, sometimes multiplying is better. So different ways, but we have to eliminate theta somehow. What is the question here? Sin theta plus cos theta is n. Secant theta plus cosecant theta is n. Somehow you have to eliminate theta and find a relation between m and n. So whatever, and I started with the answer, I think, because they asked the question only they asked n into m square minus 1. I just started with n here, secant theta plus cosecant theta, m square minus 1. M square minus 1, when I expand, I got this one. Minus 1 is also there right inside. Sin square plus cos square minus 1 cancel here. 2 sin theta cos theta will come. When I multiply these two, secant and cos will cancel, I'll get 2 sin theta. When I multiply these two, sin and cosecant will cancel, I'll get 2 cos theta. When I take 2 common, sin theta plus cos theta is n. That's how you can prove. One may say, no, I don't want to look at what they gave. I want to eliminate the theta. I want to get an idea. Then I prefer you start with n, which is secant plus cosecant. Secant you can write 1 by cos, this you can write 1 by sin and take LCM. Already sin theta plus cos theta is m given in the question. Only sin theta into cos theta you have to find. That by squaring m you can get, because what is the square of sin theta plus cos theta whole square? 1 plus 2 sin theta cos theta. You can write this in terms of m and then we'll get the answer. That's it. 47. Sin theta plus cos theta is a, tan theta plus cot theta is b. How to eliminate theta? Let us start with tan theta plus cos theta. I wrote sin by cos plus cos by sin. Take LCM, sin square plus cos square by cos into sin. Numerator is 1. Fine. So b is equal to 1 by sin theta cos theta. From a also I can get what is sin theta cos theta. How? By squaring a. Okay, if you square a, you'll get 1 plus 2 sin theta cos theta. So in that, wherever sin theta cos theta is there, you can substitute 1 by b. And this is 1 and this is a. Then that's it. You got a relation. Theta is gone and you got a relation between a and b. So just it is manipulating trigonometric identities finding. For example, here, just by looking only, you can understand by squaring and subtracting, theta will get eliminated. How? Here I have x secant theta, here I have x tan theta. When I square and subtract, secant square minus tan square is 1. Here y tan theta, y secant theta, when I square and subtract, tan square minus secant square is minus 1. And here 2xy secant theta tan theta, here 2xy secant theta cancel. So when you take a square minus b square, you ended up with x square minus y square because of using the formula that secant square minus tan square is 1. Coming to 51, a is equal to x cos square alpha plus y sin square alpha is given in the question. they want us to prove this is equal to something. You start with the x minus a into y minus a into this. Basically, wherever a is there, I'm just substitute this, nothing else. Wherever a is there, I'll just substitute x cos square alpha plus y sin square alpha. How to do that? First find x minus a alone, where in the place of a, I can write x cos square alpha plus y sin square alpha. And then take x common, 1 minus cos square alpha is sin square alpha. X minus a somehow became x minus y into sin square alpha. Y minus a, again in the place of a, just substitute what is given. And in this you take y common, 1 minus sin square alpha is cos square alpha. Pavan, you are able to follow, right?
Yes, sir.
Okay, fine. So y minus a, you substituted. 1 minus sin square alpha became this cos square alpha. I can take that cos square alpha common. I took minus cos square alpha common. I got x minus y. So now the question is x minus a into, part of the question is this. I substituted what I found here, I think this. Bringing that RHS to LHS directly, we got this, whatever they want is equal to 0. In total, what I have done is very simple. They want us to prove this is 0. And in the place of that a, I just substituted x cos square alpha plus y sin square alpha. And I simplified, everything got cancelled. In another 5 minutes, we're going to stop, don't worry. Look at 53. X secant theta is equal to 1 minus y tan theta is given. X square secant square theta is 5 plus y square tan square theta given. You have to get an idea here that when I send this y tan theta this side, what the first equation becomes x secant theta plus y tan theta is 1. Second equation, I can bring y square tan square theta to LHS. A square minus b square formula, I can write a plus b into a minus b. In that x secant theta minus y tan theta, when it is 5, when you substitute it, you'll get, x secant theta plus y tan theta equal to 1 when I substitute it. I'll get x secant theta minus y tan theta equal to 5. So directly second equation squares are there, but by writing a square minus b square as a plus b into a minus b and substituting the first equation, I got this. Now it is very easy. Look at the first equation and the new equation that we got. When you add these two equations, okay, one time y tan theta will get cancelled, will get x secant theta value. And when I subtract these two equations, x secant theta will get cancelled, I'll get y tan theta value. So I got what is x tan theta separately, what is y tan theta separately. Now we know basically what is secant theta and what is tan theta. And we have a formula that secant square minus tan square is 1. Just substitute secant in terms of x, tan in terms of y. We got a relation between x and y without any theta.